Hello friends, welcome to the day 11 session. So today we are going to discuss about what is a communication medium and how the communication is going to be executed in an Arduino. So before this, let me just run with the yesterday's session. So we have been just seen an analog write operation. So we have been just see how this PWM is going to just work with pulse width modulation. So whenever we are just providing a high signal to the analog write with the respective pin, so it is going to continuously generate a square waveform. So based on the duty cycle we are just providing here. So it is ranging from 0 to 255. 0 means off, so 255 means on. So here we have been just taken a 13th pin as LED, and analog pin variable resistor or potentiometer has been connected to the third pin, and variable has been assigned to 0. So we are here we have been just seeing how to just vary the duty cycle. So variation has been taken from a potentiometer. So that is a duty cycle. So if you are varying a potentiometer, the LED intensity is going to be varied. So we have been just seen an interrupt. So it is having interrupt attached as a function to work on it, on which pin the interrupt is going to work. Whenever the interrupt have been occurred in that respective pin, which ISR need to be just referred with, and what is a mode? We are having three modes: falling edge, low, change, falling. So low means whenever the pin turns to low. So change means changing its state from high to low or low to high. Falling means a falling edge from high to low. So this is like we are having some of the conditions. The ISR should be short and it should be faster. And wherever you are using a state, all the variables should be globally declared. So these two variables should be globally declared, and it should be declared with a data type called volatile. So later we have been just connected one of a temperature sensor, and we have been just seen how exactly the temperature, or how to just connect or a coding part for this LM35. So LM35 is analog sensor. It has been just connected to the A0, and for every 1 degree rise, 10 millivolts of voltage will be increased at the middle pin of LM35. So that is what the code has been just provided. This is a serial communication which has been begun with a baud rate of 9600. So today we are going to see about communication protocols. So communication protocols means the set of rules. Protocols means a set of rules which have been just provided for making a communication between devices. It can be two microcontrollers, or it can be between any of our ICs. So here you are going to sit with a communication protocol. So here we are just seeing that hundreds of communication protocol has been just defined to make a connection between two microcontrollers or two ICs. So here we are going to broadly classify our communication into two types. First one is parallel communication, and the second one is serial communication. So first one is parallel and the second one is serial, one after the other. So if you are having a microcontroller, if it is a serial, only one line is going to be just carrying the data. So whereas in a parallel connection, you are having a series of pins, so you are going to have more number of pins, IO pins. So let us see what is parallel communication. So parallel communication, which have been connects the Arduino and the peripherals via input or output ports, ideally if and only if the distance is between two transmitter and receiver or less. So what it is going to do is, so it is going to connect the Arduino or with a peripherals, and peripherals if and only if the distance between these two are too much less. So this is the first and foremost thing. So that will be in the meters, so some meters. So like however, in the case whenever we are going to establish a communication between two devices, if it is more than, if it is a longer distance, parallel communication doesn't work. So it is going to just fail over there. Why? Because we are going to transmit multiple bits of data. So multiple bits are going to be transformed from transmitter to receiver. Hence the shorter distance is feasible. And this is faster communication as compared to a serial one. So here it is having a some of advantage, faster than serial, easy to implement compared to a serial communication. So this is a, consider this as a microcontrollers. So two microcontrollers. So we need too many of pins. See, like if you are going to transmit any of a information called so we'll be having some 8 bits, 1 2 3 4. See, like if you are going to transmit a information called A, it will be just converted into an ASCII values into 8 slots, and some numbers will be transmitted like this. So this is called as an parallel communication. 8 bits have been sent at a time. So it is like whenever a first bit is going to be sent, all the 8 bits are going to transfer from one sender to another receiver. So we are having 8 pins or 8 bits here. So the main advantage here is it is faster and it has been used only for shorter distance, and multiple bits are going to be transmitted at a time simultaneously. So that is called as a parallel communication. So the disadvantage here is need more number of IO pins here. So IO pins need to be connected. So it is going to have more number of IO pins. So these are all the IO pins which are being connected. So we need more number of IO pins compared to the serial communication. So whenever we are going to implement microcontroller or a microprocessor, so these more number of IO pins are not able to sustain in a manufacturing sector. So initially in a printers, you are going to see these kinds of a structure. It will be having more number of pins like this, around 20 to 25. Or initial monitors also, it was having some 6 to 8 pins like this. So these are all the some of parallel communication examples. Now it has been just replaced with USB protocol in a system. Everything have been just done before the USB protocol. To avoid all these devices, one device have been replaced, even for monitors. So the next one is a serial communication. So this is a standard communication protocol which have been just used. I was speaking about serial communication is a standard communication protocol which have been used nowadays in an Arduino. So in Arduino we are going to just see this is a standard protocol which have been used for having a communications. So this is a standard protocol which have been used for communication. On what factors actually we are going to decide which communication we need to just opt with. See, like with how many devices does your microcontroller need to communicate? See, if it is 1, 2, 3, what is how many devices does your microcontroller need to communicate with the other devices? So that is the first and foremost factor. You need a faster or slower communication. So if you need faster and the distance is less, you can go for parallel. If it is fine, you can with a slower version, and the cost will also reduce with the serial communication. So you can just convert to the serial communications. So what is the distance? Another parameter, distance between transmitter and receiver. And if the condition is like you need to transmit the data and receive the data simultaneously. So these are all the factors which are going to just which type of applications what the user is going to do with. So these factors will be able to decide which communication models we can just select with. So the next one is types of serial communication. So we are having two types here. So the first one is synchronous. So synchronous means, so you are having a one transmitter, you are having a receiver, you are having a clock, and you are having a data pin. So synchronous means with respect to clock, the data is going to be pushed. So whenever there is a change in a clock cycle, the data is going to be shifted in the form of shift resistors. One by one, it is going to just shift. So here we'll be having some shift resistors at both the transmitter and receiver. For every clock, the data is shifted by 1 bit. So here again we are having uh, three types. One is rising edge, another one is falling edge, and another one is level edge. So based on the sensitivity what we have been set it. So if we have been set it for rising edge, the data is going to be changed for rising edge. If we have been set it for falling edge, the data is going to be changed at a falling edge. And the third one is level trigger. So we are having a shift resistors to transmit and receive. So synchronous and asynchronous. So in asynchronous, so you are having only a data pins. So it has been cross connected like this. But you will be having some common baud rate or a clock to just between a transmitter and receiver. So the main difference is going to lie here. So here also we'll be having a common clock. So that is being just provided here. So here the thing is, data is not changing with respect to clock, but both transmitter and receiver are going to be set to one of a baud rate. So that is called as an asynchronous. So here also we'll be having baud rate, and here also we'll be having baud rate with a clock. Both the side will be having a common clock between transmitter and receiver, but while sending a data, clock is present in synchronous. While sending a data, clock is not present in asynchronous. Only while sending a data. So before transmitting, some agreement need to happen between transmitter and receiver. It can be synchronous transmitter or it can be asynchronous transmitter. So that agreement is called as a common clock. So in asynchronous baud rate, so here also we'll be having a common clock. So these are the types of a, so what is this communication? I guess you have been just seen what is the difference between asynchronous and an asynchronous, which have been just posted in your Google Classroom. I guess you have been just seen. I have just brushed it up. So what are all the bits which are going to be used in an respective serial communication? So for an example, for an serial communication, we are going to take an UART. So universal asynchronous transmitter and receiver. So this is one of an example which have been used for asynchronous model. So asynchronous model will be having same like some set of rules. So all the communication medium will be having some set of rules. See, like due to these rules, there will be some lesser errors. So lesser or no errors. So there will be a mechanism in which an external clock between transmitter and receiver is going to be connected. So first we are going to see about synchronous bit. We will be having synchronous bit, data bits, parity bits, baud rate. So let me just write a one sample data frame. So we'll be having one start bit, we'll be having a data length D0, D1 to D7. So you will be having one or two stop bits. It's based on the user, the selection. So synchronous bits are the one which have been just there is an example, like if the bits per second is 300, you can just transmit a maximum of 37, what is this, bytes. So this is a maximum value and the minimum value of 27 bytes. So this is a minimum value and this is a maximum value if the baud rate is 300 bits per second. So next, how to write a program in an UART. Write a program for an UART in an Arduino. So UART is a one which is going to just make a asynchronous communication between transmitter and receiver. So let me just show you. I guess you have been just seeing the serial monitor. So this, so void setup. So this is, I guess you have been just, you are knowing about this, you have been just seen what is a serial monitor. So this is an UART example. So here is a baud rate. So if you are sending with a 19,200, you need to change the baud rate. If you are sending with 9,600, you need to just mention the baud rate here. So in a void loop, you can use serial print or serial println to just transmit the information from transmitter to receivers. Okay, then let us write a simple, what is this? Let us write a simple program. Whatever the user is typed, just display on serial monitor. So this is what setup. So in a void loop, so we can have this thing, to flower bracket inside it. We are just writing a if condition if serial is available, mean to say whenever there is a data in an serial buffer, you need to enter this if condition. So here we are going to just make, so we are going to just type serial.print. So I received data from keyboard. So what it is received, we need to just do here. So serial write. So what you are going to read. So you are going to write the information onto the serial monitor by fetching the data from a keyboard. So this is like how to just go with. So here you are going to start a communication with baud rate of 9600. So here you are checking whether the alphabets or any of the information is available on the serial monitor. If it is available, go inside it, print receive data from keyboard, and in the next line you can just go for printing the received data. So this is a one which have been just a simple code we can just see with. So we can just see the same thing on an respective Arduino. So here we are having serial write. So serial print and serial print ln will return the exact ASCII value of what you have been sent, whereas serial write is a one which is going to send the exact text what you are going to be just provided with. Okay, we can just copy this. So begin with the communication, received the data, we can just check for the UART1 whether it is having any errors or not. So I have been connected a device here. So whenever you need to use what is this serial monitor or UART, you need a hardware. Okay, it is checking for an errors here. So it is going to take some time to compile the results. So what the thing is, you need to just see with what is our condition here. Whenever the key have been pressed from a keyboard, so then wait a second. Okay, it is not having an error. If a key have been pressed from a keyboard, it enters here, or else it will be inside the void loop itself. Okay, we can just upload it. So once it has been uploaded, the LED will be start to blink. So in a serial monitor, so whenever I am pressing any of a key, after pressing a enter button, or I can just press a send here, soon after it need to be displayed. So the received data from the keyboard is A. So this is what whatever you are just sending, that will be just printed. So like this, bit by bit. So each character will be taking 8 bits. So it is going to just have a received data is A, S, D, F, G. So this is a one what we are going to just do. So this is a simple program to use your UART to get the information that what the user have been provided for it. And that is an automatic version. Soon after you are sending, you will be receiving on the serial monitor window. So the next one is in order to make a communication inside or in between the microcontroller, we are having some of our protocols called SPI, and another famous protocol is bus infrastructure is I2C. So you need to read it as I2C. So SPI, and this is another protocol. So this is I2C is used for having a serial communication between the systems. So you need to have, if you need to have a serial communication between two microcontrollers, you can use this I2C buses. So this I2C buses are the one which have been used for short distance communication. If the length is too much high, you cannot use for I2C. So this is meant for shorter distance. So in order to connect the two microcontrollers, you are using two connectors, or you are going to have two bridges here. One is for clock signal for synchronizing the both transmitter and receiver, and another one is for transmitting the data. So this is called, you need two connectors to make a connection between transmitter and receivers. So here it is used to control the slave devices. So this is a master, and it will be connected to some of our slave devices. Through the address, the master is going to communicate with any one of a slave at a time. So using this I2C, you can control up to 1012 different applications, or 112 different devices can be connected to the master. So the master is going to select the slave based on the protocol, that will be based on the address, and you will be having some of the wires need to be connected whenever the master is transmitting a data and slave is receiving, and whenever the slave is transmitting and master is receiving. So this is the one arrangement which are being just made with. So it is a serial data exchange between microcontroller and ICs. So I2C pins is having two pins. So first one is for SCL and the second one is SDL. So one is for clock signal, another one is for transmitting the data. So this is the two pins which are being provided. So when every time the master will be generating the clock cycle. So this is a mandatory thing. Every time master will generate a clock cycles. So some slaves devices may have the clock low at a time. So whenever it is busy, so it is going to make a low clock signals. So it is a indication saying that the slave is been using has been just carried out in its task. So it is doing some task. So this time is going to be called it as a clock stretching time. The slave is going to take some more time to just decode the respective information sent from the master. So to do this, it is going to make the clock signal as low. So we are going to just have a master as a transmitter and slave as a receiver. So whenever this is a scenario, these are all the pins which are being used at the master to have a transmission. So the next is wire.begin. So it is going to have a 7-bit address of a slave. So it is going to generate a 7-bit address of a slave. So this master is going to generate a slave address. So that is going to be initiated by wire.begin. Whenever the address is not matched, the slave will be not connected to the master. So it will be go on pushing that address to each and every slaves. Wherever the address is found, it is going to make a next move. So the next move is wire.begin address. So in the previous state, the address will be found, that address will be pushed here. And what is the thing is going to make is, it is going to start the transmission by sending a clock signals. So after a synchronization, it is going to send wire.write. So this is a function where some bytes of information is going to be transmitted between transmitter and a slave, that is master and the slave. Once the transmission, see like this wire.write will be continuously transmitting the bytes till it is going to get a end of a transmission. So when this wire.end transmission is sent, so the communication has been ended. So it has been successfully sent a data from master to slave. So whereas slave as a receiver, so slave as a receiver, here also it will be of having 7-bit address. It will be continuously seeing this bus. Whenever its address have been found, it is going to be activated. So wire on receiver. So it is a handler which is a function to be called when the slave device receives the data from a master. So whenever the slave receives the data from the master, so this is a handler which is going to be called. So this is same as an interrupt, but it will work with a perfect protocols. So whenever this address have been found, it will be start receiving. Whenever it has been received, it is going to call this function. So the next one is wire.available. So this is a thing returns the So this is a function which is going to be called with a wire.read, and this one will be inside this wire.receiver. So this is going to retrieve the number of bytes. So this is like what is master device and what is a slave, which is going to be just master is going to act as a transmitter and slave is going to act as a receiver. So we can just see the output here. Okay, sorry, not output, how to code for master and slave. So we can just see with the sum of a coding part here. So first we are going to include #include wire.h. So this is a header you need to just work with. You need to place that header in an Arduino working directory in an library files. So in a void setup, you need to say wire.begin. So you can have some of a global variable like the data type of it is a short, and you can just go for void loop. So in a void loop, you are going to write all the commands what you have been just seeing here. Wire begin transmission, wire write, wire end transmission. So first one is wire begin transmission. So here the communication have been just started. Whenever the address have been found, we are going to just say that, so you are going to send to that respective address. So here it is going to move for the device second. So address have been found and you are using a wire dot write operation. What you are writing? The age. Okay, the age of the person is. You are writing this, and again you are sending a data from a microcontroller. What you are sending? Age. So the age here is 0. So age is a variable which is going to store the 0 value and it is going to be transmitted here. So then after transmitting, you are ending the transmission. So this is a respective program which can be used to perform a connecting a master and slave. So here you have been transmitted with the address 2. So what you are transmitting is the age of a person is. So this is the first transmission. After successful of a transmission, again you are using the same command to send a age information. After transmitting a data, you can just make it as end transmission. After every end, you are waiting for 1 second. So this was like for an transmitter side. So that is a master side. So here, whenever it becomes for slave as a receiver. So here also you need to include #include wire.h. Okay, wire is caps. So wire.h void setup. So in a void setup, you are going to begin with the address which have been provided by the master. So after begin, you are going to make it as a wire dot on receiver. So you are going to have some receive event. So you are going to call this event. So whenever the master is going to send a data, you are going to call this function. So next you are going to make some serial communication with a baud rate of 9600. So in a void loop, you are just generating a delay here. Some milliseconds of delay will be generated. So this is going to happen, and here you need to write a function for this receive event. So void receive event. So how many bits are going to be just provided? How many bits? So while wire is available, so same as this what we have been just seen in an UART communication. When it is serial is available, you are going to send the data. When wire is greater than 1, when it is available, so you are inside this loop. So this, if this condition is false, then you are going to come out of this loop. So char C is equal to wire dot read operation. You are going to read characters using a read command, and you are going to print it. What you are going to print? The readed value from a wire. So this was like for serial slave as a receiver, and this master is going to send the data with the address 2. So here you have been just mentioned the address for slave. So like this, whenever the data is available, you are reading it and you are printing it. So this is for having a master as a transmitter and slave as a, so master as a transmitter and slave as a receiver. So here comes the reverse operation of it. So master has been just requesting a data from a slave. So this is another type of scenario. So whenever you are being connected some of the sensors to the slaves, so the master will be waiting to get the information from the slaves. So that is the version programmed to receive the data from a slave, but whereas slave will be acting as a transmitter. So here master slave will be requesting from address and how many bits is going to be just requested from the slave. So based on the request, on request it is going to call the handler. So handler means sub-program. We can just see this, the same version of code what we have been just seen, but with a slighter difference. So same thing, hash include wire.h. So we are going to use void setup. So inside a void setup, you are going to begin the data. So begin the communication, and you are going to make a serial begin as well with a baud rate of 9600. So next one is void loop. So in the void loop, you are going to have a request from handler. And how many bits you are receiving. So this is saying that from device 2 you are receiving 10 bytes. So then while wire is available, while wire is available, you enter into this while loop and be in the while loop till this condition is going to be false. So the same thing, so while read, so if it is greater than 1 you can enter. So cache, so serial dot print, what you are printing, C. So after this, after receiving everything, you can generate some milliseconds of delay. So this is for master receiver. So next I am going for slave as a transmitter. So again you'll be having a same void loop and hash include for this, but you are going to just change some of the things here. Wire on request. So wires on. So this is being just seen in the slide. So what is the thing is, you are going to write a subprogram called request E or a request event. Anything is fine. So after this you are going to have some of data type called byte of x is equal to 0. So in a void loop, so you are going to just generate a delay of some milliseconds. So now you need to write a subprogram for this, what it is going to perform. So what it is going to do, it is not going to take any of the tokens or parameters. So why write the content of x? So x is a global variable so that it can be accessed everywhere. So you can increment the x plus plus. So this is a condition where the respective master is going to act as a receiver and slave is going to act as a transmitter. So that's it for this video, guys. So here we have been just started with what is a serial, what is a communication protocols, why we need a protocols and all. So we have been seeing what is parallel communication. So you are going to send all the data in parallel. So these are the advantages and disadvantages, and what is serial communication and what are the factors which are being just dependent to decide what type of communication we need to carry. So the next one, synchronous and asynchronous, the types, and we have been just seeing what are the bits used in UART, and we have been seeing how to use a UART communication in Arduino, and we have been seeing a very important bus structure is I2C bus, and we have been just seeing the pins, and we have been just been seeing how to act master as a transmitter and slave as a receiver, and reverse operation of it, slave as a transmitter and master as a receiver. So that's it for this video, guys. Let us meet you in the next video. Thank you.